Hi children, hello, welcome to your homeschool. This year class 10 mathematics NCERT or CBSE board, and we are in our chapter 8 real numbers. This is your last session of your real numbers. Before starting our exercise 8.4, we are going to discuss with the small three theorems. Only statement is important, there is no need of any proof. And before starting this, we are going to discuss something here. What is that? We know about 4 or 5 words. What is that? Terminating, non-terminating, recurring, non-recurring. This is all you might have heard, right? So just see here. You can see a decimal expansion. By seeing decimal expansion, we are going to identify. So your answer is 4.12. 4.12 means what? It is a decimal and there is an end for the decimal. 4.12 stopped means there is no extra numbers here. Means it is a terminating decimal expansion. Terminating means stopping. There is an end. Right? Your answer is this much only. It is a terminating decimal expansion we say. Now look here. What is this children? 8.174174174. So something you can see. What is that? After decimal, this value is repeating. What is that? 174174 is repeating. So this in other ways I can write it as 8.174 repeated. The bar indicates these numbers are repeating. So this type of decimal expansion, what do we call? The decimal expansion is non-terminating. Non-terminating means there is no end. Dot 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 indicates it is a never-ending expansion. Therefore, what we say? It is a non-terminating and the decimals are repeated here. Non-terminating, repeating decimal expansion. Repeating decimal. Non-terminating means there is no end for this expansion. The decimal expansion is a non-terminating and a repeating decimal expansion. Now, have a look here children. What is that? 3.1415926535. By the way, what is this? This value is nothing but pi value. What is a pi? 22 by 7. If you divide that rational number, you are going to get this. Okay, you are going to get this one. So this is a never-ending expansion. This type of a decimal expansion, what do we call? It is a non-terminating, means there is no end. So on indicates non-terminating. Non-terminating, non-repeating, and there is no number, it is repeated. Non-terminating, non-terminating, non-recurring. You may say repeating or recurring children, or here non-repeating, or I can say it as non-recurring. Non-terminating, non-recurring decimal expansion. Decimal expansion. So these type of decimal expansion, understand here carefully children. Only this point if you get, we call such numbers as irrational numbers. Understand here, terminating decimal is we can convert into rational. And whereas a non-terminating recurring decimal also we can convert into rational. But whereas non-terminating, non-recurring cannot be converted into rational. Therefore, that type of number is called as a irrational decimal expansions. So one more example here. 2 by 3. 2 by 3 if you divide, what you are going to get? 0.6666. That 6 never ends. Right? So this type of decimal expansion, what do we call? Repeating. It is continuously repeating decimal, right? It is a non-terminating repeating decimal expansion. 1 by 3. 1 by 3 is also a non-terminating and repeating decimal expansion. So one more example you can say here. 2.416785 432. If I stop there, which type of a decimal expansion it is? You just see here carefully, there is an end for your value. Means it is terminated. This decimal expansion is a terminating decimal expansion. Okay, understand the 4 words carefully. Terminating, non-terminating. Suppose if I write here 2.416785432 so on. Non-terminating. Is it a terminating? No. It is a non-terminating, non-repeating decimal expansion. Okay, once again, let's have all these 4 words here. What is that? This decimal expansion, there is an end, therefore it is a terminating decimal. And here there is no end and it is repeating. What do we say? Non-terminating, repeating decimal. And this one, non-terminating, non-repeating decimal expansion. And this one, terminating decimal expansion. And here this one it is non-terminating, non-repeating decimal. And this one it is non-terminating, repeating or recurring decimal. Non-terminating, repeating decimal. Like this, you just understand these all concepts. Then we see the statements. Let's see the statement of Theorem 8.5. Let x be a rational number. Let x be a rational number whose decimal expansion terminates. Terminates means there is an end for that decimal expansion. Then x can be expressed in the form p by q. Suppose let me take here x is equal to p by q. I have expressed, children, it is 3 by 8. X can be expressed in the form p by q where p and q are co-primes. Let us see whether they are co-primes or not. Yes, 3 and 8 are co-primes. Why? There is no common factor other than 1. And the prime factorization of q is of the form 2 power n 5 power m, where n, m are non-negative integers. What are co-primes, children? That means there is no other common factor other than 1. Non-negative integers. What are non-negative integers? Only positive integers. Look here carefully. I have taken x be a rational number. I have expressed that in the form of p by q. That is 3 by 8. Now, split this 8, children. Write the factors of 8. What are the factors of 8? I can write it as 2 into 2 into 2. That means 2 power 3. Okay. Understand the statement carefully. Q is of the form 2 power n 5 power m. 2 power n. It is in the form of n. N is a positive, means non-negative integer. N is equal to 3 you have. But there is no 5 power m. When there is no 5 power n, I can assume it as 5 power 0. If you want, you can write there numerator also 5 power 0. 5 power 0 means what? 1. So, denominator is a multiple of 2 and 5. That means it is in the form of 2 power n and 5 power m. Therefore, if you have your denominator factors are in the form of 2 and 5, then what I can say, children? I can say that this is a terminating decimal. Or we can write equivalent fraction for this. Look here carefully. 2 cube there. So I just multiply numerator and denominator with 5 cube. What happens now? Denominator. Numerator 3 into 5 5 is 25. 25 5 is 125. And now 10 whole cube. 2 cube into 5 cube whole single bracket if I write 2 into 5 whole power 3. That is 10 cube I have written. So now multiply this one, children. 3 5s 15, 3 to 6, 7, 375 by 10 cube. How can you write this? 0.375. This is the answer for 3 by 8. What is the answer for 3 by 8? It will be 0.375. Means this decimal expansion, there is an end. Therefore, we say that it is a terminating decimal. How can we identify whether it is a terminating or non-terminating? Observe here, in the denominator, either 2 or either 5 or both if there, then that type of a rational number, its decimal expansion will be terminating. Other than 2 or 5, any other number there in the denominator, directly you can say that it is non-terminating decimal expansion. Okay, let's see one more example here. 7 by 80. Let me write this as 2 2s are 4, 4 2s are 8, and 10 means 2 into 5, right? 2 power 4 into 5 I have in the denominator. What are the factors of cube? 2 and 5 there. But I want to make equivalent fraction. So for that I am going to multiply here cube. Cube means it becomes 4 into 5 cube. Here, look here carefully, 1 5 already there. So I have multiplied 3 5s in the denominator as well as in the numerator. Now, what does it become? 7 into 125 by 2 into 5 whole power 4, that will be 10 power 4. Now multiply this one. 7 5s are 35, 7 2s are 14, 14 plus 3, 17, 7 1s are 7, 8, that will be 10 power 4. So how do you write this decimal, children? 0.0875 is the decimal expansion for this. Now 0.0875, what you can see by seeing this decimal expansion? This decimal expansion is a terminating decimal. So when we have in your denominator multiples of 2 and 5, that means 2 power n and 5 power m, where n and m are non-negative integers. We say such type of rational numbers have a terminating decimal expansion. Theorem 8.6. Let x equal to p by q be a rational number such that the prime factorization of q means denominator, is of the form 2 power n into 5 power m, where n, m are non-negative integers, then x has a decimal expansion which terminates. See here children, both the statements are similar. Example, whatever the examples we have done, it correlates with this theorem statement also. Let x is equal to p by q is a rational number such that the prime factorization of q is of the form 2 power n and 5 power m. n, m are non-negative integers, then x has a decimal expansion which terminates. With the examples, we have seen already the statement. See the next one, Theorem 8.7. Let x is equal to p by q. Again, it is a rational number. Be a rational number such that the prime factorization of q means denominator is not of the form 2 power n and 5 power m, where n, n, m are non-negative integers. Then x has a decimal expansion which is non-terminating and repeating. Let us take an example, 1 by 7. So observe here it is in the form of p by q, where q, what are the factors of q children? 7 and 1, that's all. There is no other factors. So denominator q is not in the form of 2 power n and 5 power m. Q is not equal to 2 power n and 5 power m. So directly I can say it is a non-terminating repeating decimal I can say. But if you divide and check, you are going to get 1 by 7 is equal to 0.142857, and from here onwards it repeats. How can we rewrite this? 0.142857, and these 5 digits are repeating. So you can write like this, 1 by 7 is equal to 0.142857, whereas this rational number is a non-terminating repeating decimal expansion. Finally, we get to a conclusion children by seeing these 3 statements. What I can say? Any rational number when it is converted into decimal, the decimal expansion of having terminating decimal or a non-terminating recurring decimals are nothing but the rational numbers. Suppose only one condition, we have to accept that it is an irrational number. Where it is? It is a non-terminating, non-repeating decimal expansion. If you got, blindly we can say that it is a irrational number. Let's start our exercise 8.4 and your first main. What is your main heading, children? Without actually doing long division, you just find whether the decimal expansion will be terminating or non-terminating and recurring. So without doing division, we need to find. How can we find? Look here, first problem, 13 by 3125. How can we write the denominator, children? We know the LCM, right? 3, 1, 2, 5. Do LCM. 5 6 are 30, 5 2s are 10, 5 5s are 25. 5 1s, 5 2s, 5 5s. Again, 5 2s, 5 5s. 5 5. So, finally I can write it as 5 into 5 into 5 into 5. That is 5 power 5. So, I have written this denominator in the form of 5 power 5. Like this, we need to convert the given denominator right in the form of multiples of their factors. I have done the factors by doing the LCM. Look here, children, 5 power 5 there. Check whether it is a terminating decimal expansion you are going to get or non-terminating and recurring. How can we check whether our denominator is in the form of 2 power n and 5 power m? If there, it will be a terminating decimal expansion. So look here, 5 power 5 there. So I can multiply here 2 power 0. 2 power 0 makes 1. Since the factors of denominators are 2 power 0 and 5 power 5. Therefore, 13 by 3125 is a terminating decimal expansion. Is a terminating decimal expansion you are going to get, children. Right? Without doing division, we can directly say this answer. Similarly, look here, 17 by 8. How can you write 8? 2 2s are 4, 4 2s are 8. 2 cube there. Can I multiply into 5 power 0? Yes, 5 power 0 value is 1. So, denominator, you can write same statement. Since the factors of denominators are 2 cube and 5 power 0. Therefore, 17 by 8 is a terminating decimal expansion. Okay, just see whether your denominator is in the form of 2 power n and 5 power m. If there, it is a terminating. If not there, non-terminating and repeating decimal. So look here, 64 by 455. Convert the denominator, children. Find the factors. So just do like this. 5 9s are 5 1s are. So further can you do? 7 1s are 7 3s are. That's it. So 64 by 5 into 7 into 13 there. Oh my God, 7 and 13 are extra. We need in our denominator only 2 and 5. If there, it will be a terminating. Other than that there, what I can say? Therefore, 64 by 455. Therefore, the factors are 5, 7, 13. You can write this all. Is a non-terminating. So, your decimal expansion, you can guess that it is a non-terminating and recurring decimal expansion. You are going to get non-terminating and recurring decimal expansion. See the fourth one, 15 by 1600. 15, you can rewrite it as 3 5s are 15. 1600, I have done LCM. If you want, you can check once again. 1600 to 800s to 400s and 200s, then 250s, again 5 10s, 2 5s. So look here, how many 2s you can see? 1 2 3 4 5 6 2s. So I have written 2 power 6. 2 5s you can see, 5 square I have written. Okay, you can see that it is in the form of 2 power n and 5 power m. Yeah, denominator q value is in the form of 2 power n and 5 power n. Therefore, what I can say, the factors of the denominator are 2 power 6 and 5 power 2. Therefore, 15 by 1600 is a terminating decimal expansion. Is a terminating decimal expansion. Okay. See the next fifth one, 29 by 343. Denominator, how can you write, children? 29 by 7 cube I can say. 7 7s are 49, 49 7s are 343. 7 cube. So your denominator, you don't have a factors of 2 and 5. Other than 2 and 5 we have in cube place. So what I can say? Therefore 29 by 343 is non-terminating repeating decimal you are going to get. Next, see the sixth one, 23 by 2 cube 5 square. Directly you can see that the denominator q is in the form of 2 power n and 5 power m. Therefore, the factors of the denominator are 2 power 3 and 5 power 2. Therefore, 23 by 2 cube into 5 square is a terminating decimal expansion. Is a terminating decimal expansion. Next one, seventh one, 129 by 2 square 5 power 7 7 power 5. Directly I can say no. Why? You have denominator other than 2 5 another value there. That is 7 there. So I can say that therefore 129 by 2 square 5 power 7 7 power 4 is a non-terminating repeating decimal. Non-terminating repeating decimal you are going to get. Repeating decimal expansion you are going to get answer. See the eighth one, 6 by 15. How can you write, children? 3 2s are 6, 3 5s are 15. 3 3 cancel. 2 by 5 you have. 2 by 5 means you can just multiply 2 power 0, right? Therefore, what I can say, 6 by 15 is a terminating decimal expansion you write. Right? See the ninth one, 35. 7 5s are 35. 50, you can write it as 5 10s. 5 5 cancel. Your denominator is readily 10. Either it may be a multiple of 2 and 5 or 10 if there it is a terminating. Therefore 35 by 50 is a terminating decimal expansion. See the last one, 77 by 210. How can you write, children? 7 11s are. And this one 7 into 3 into 10 you can write. 7 7 cancel. Though you have 10 and extra 3 there. So in your denominator other than 10, 2 5 other than 2 5 10 there. If extra any number there, you can say that. Therefore 77 by 210 is a non-terminating repeating decimal. Non-terminating repeating decimal expansion you are going to get. Let's see the second mean. What is your second mean here, children? Write down the decimal expansion of the rational numbers which is having a terminating decimal expansion. As we have done in our first mean, we know which problem is terminating. So look here, I have deleted third one and here seventh one and their 10th one. Those are all, they are not terminating, right? Only terminating problems you convert into decimal they asked. So look here, how to convert. It's very easy. See the first problem, 13 by 3125. Denominator convert into 10 power, right? If you are able to convert denominator into 10, then it is very easy to convert into decimal. Look here carefully. You have 3125 means 5 power 5. So if I need to make this cube in the form of 10 power means I need to multiply 2 power 5. Multiply numerator and denominator by 2 power 5. So what happens? 2 power 5. How much count children? 2 2s are 4, 4 2s are 8, 8 is 16, 16 2s are 32. So 13 into 32 by, I will write in a single bracket 5 into 2 whole power 5. What is 13 into 32? 416. Or directly you can calculate children. 3 2s are 6, 3 3s are 9. 32 1s are 32. Add this 11, 4, 4 1 6. 416 by 10 power 5. Now it is very easy to convert into decimal. Almost your conversion is completed. 10 power 5 means how many zeros you will be having? 5 zeros, right? That 5 zeros, when you convert into the numerator, what happens? You are going to put a dot. After how many numbers? After 5 decimal numbers. 1, 2, 3 only. 3 digits only you have. So what you need to do? 4, 5, put a point. This is your answer. What is the decimal expansion of 13 by 3125? It is 0.00416. Once again I repeat, how did we do this one? Observe the denominator, 5 power 5 there. So what you multiply to get into 10 power 5? 2 power 5 should be multiplied. Multiply for numerator and denominator, right? Numerators you multiply, denominators also you multiply and write. 10 power 5 means you will be having 5 zeros. That if you want to convert into decimal expansion, you need to put a point before 5 decimal values. Now next one, second problem. 17 by 8 can be written as 17 by 2 cube. 2 cube was there. What is missing? 5 cube. So multiply numerator and denominator 5 cube. Why children here 2 cube there? I need 10 cube. 10 cube how could I get? If I multiply 5 cube, I can get 10 cube. Now 17 into 5 cube will be 5 5 is 25, 25 5 is 125 by 10 whole cube. Right? Now calculate this. 125 into 17. 7 5 is 35, 7 2 is 14, 8 75 and this will be 125. Finally your answer is 2125. Write it here, 2125 by 10 cube means 3 zeros. Now bring the zeros up. How will you do? Decimal point. 2.125 is your answer. 17 by 8 decimal expansion is 2.125. Is this decimal expansion terminating? Yes, there is an end, therefore it is terminating. See the next one. 15 by 1600 is equal to, I can split this as 3 into 5 by 2 power 6 into 5 square. Now you need to think more. 2 power 6, observe here children. Beside I need 5 power 6. Already 2 there. Still how many needed in 6 if you subtract 2? 4 you need. So multiply 5 power 4 for numerator and also denominator. Now what does the denominator becomes? 2 into 5 whole power 6. Now numerators multiply. 5 3s are 15, 5 5s are 25, 25 25s are 625. Now multiply these two. 625 into 15. 5 5 is 25, 10, 12, 31 and this will be 625, 7, 3, 9. Now finally 9375 by 10 power 6. Now rewrite children, convert into decimal. After 6 values you need to put a point. 5, 7, 3, 9. Only 4 digits you have. 56.0. What's your answer? 0.009375 is your answer. See the next one, sixth one, 23 by 2 cube into 5 square. So here, observe here, 2 power 3 means I need to make denominator 5 also in the form of 5 cube. 5 power 2 there, so let's multiply 5 for numerator and denominator. Then it will be 23 5s are 5 3s are 15, 5 2s are 10, 11 by 10 whole cube. That will be 115 by 1000. Bring to the numerator, convert into decimal, that makes 0.115 is your answer. See the next one, 6 by 15. 2 into 3, 3 into 5 we have written, 3 cancel. And it will be 2 by 5. I need to make denominator in the form of 10. So just multiply 2, then it becomes 10. 2 multiply for numerator and denominator. It will be 4 by 10. Directly you can write 0.4 is your terminating decimal expansion. Ninth one, 35 by 50. 5 into 7 and 5 into 10 we have done 5 cancel. It will be 7 by 10. Directly you can write it as 0.7. This is the way we need to convert decimal expansion. See the last main of this chapter, that is your third main. They have given the decimal expansions. Check whether it is rational or irrational and of the form P by Q. What can you say about the prime factor of Q is your main heading. Let us see 3 sub-questions here. See the first one, 43.123456789. Observe this decimal expansion. What can you say? The decimal expansion is a terminating decimal. If it is a terminating decimal, then it will be a rational number. So rewrite this decimal expansion, children. You can write it as 4312345678 9. Okay. So after decimal point, how many decimal places you have? It will be 9. So put here 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Like this, you need to rewrite the decimal into rational. Therefore, I can say it is a terminating decimal. It is a terminating decimal expansion. Therefore, it is a rational number. Convert in the form of P by Q asked. I have converted in the form of P by Q. What can you say about the prime factor of Q asked? I can say that Q, this is P by Q, right? Prime factor of Q. Q is in the form of 2 power n into 5 power m. Or directly you can say 10 power. It is in the form of 10 power 9 you have. Right? 10 means I can split in the form of 2 and 5, right? 2 power 9 and 5 power 9. That is 10 power 9 you have. Therefore, Q is equal to 10 power 9 you can say. See the second one. 0.120, so on. So by seeing this decimal expansion, what can you say? This decimal expansion is non-terminating. There is no end for this expansion. Non-terminating, is it recurring or repeating? No, it's not repeating. Therefore, it is non-terminating and non-repeating decimal expansion. If it is a non-repeating and non-terminating, we can say that therefore it is not a rational number. We cannot convert this into rational number. It is a irrational number. Okay, so we cannot convert into rational number. So how can we get P by Q form and Q value? We can't say. So therefore it is not a rational number. Irrational number decimal expansion is this. See the third one, little difficult, understand carefully. 43.123456789 bar indicates it is a repeating. These many decimals are repeating again and again. Right? So by observing, I can say that it is a non-terminating, repeating decimal expansion. But we need to write in the form of a rational number, right? P by Q form and say about Q. First, convert this to rational number. How can we convert these type of repeating decimals? So how many decimals are repeating? Look here, children. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Suppose, let me assume this as X. 43.12345678 bar. I need to multiply like this. 4, 5, 6, 7, 8, 9, X. So 9 zeros, 1. That is 100 crores. You need to multiply. Into X is equal to. What happens now if I multiply? That decimal point will be shifted here. 43123456789 repeated now children. After this decimal point again it repeats. So now you need to subtract this with this. So when you are subtracting, what happens here? Point minus, you rewrite this X value here. 43.123456789 bar. So when we are subtracting, what happens after this decimal point? Both are same. So this becomes 0 children. So these two you subtract now. 4, 3, 1, 2, 3, 4, 5, 6, 7. When you are subtracting, 9 minus 3 will be 6. 8 minus 4 will be 4. Is equal to left hand side what you have. So you need to subtract this minus 1x. 1 there. If you subtract 1, what happens here? How many zeros you have? 9 zeros, right? When you subtract 1, then it becomes 9 nines. 100 minus 1, 99. 1000 minus 1, what happens here? 999. So here itself 9 nines you are going to get. 4, 5, 6, 7, 8, 9, X. Now this multiple, send this side. 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6 by 9s, 9 nines. 9s. Okay, so now it is in the form of P by Q. It is in which form, children? P by Q form it was there. So now finally, observe the prime factor of Q side. Therefore, Q is 9999999. 9 nines you will be having. I can see that Q is having a factor other than 25. Okay, that only you can say here, children. Therefore, Q is having a factor other than 2 and 5. Okay, where this is a rational number. You can write here. Therefore, the given decimal 43.123456789 bar is a rational number, and it is in the form of P by Q. We have converted, and what is your Q value also we have written. So it's not so easy, children. Once again, understand the problem carefully, what we have done. So, how many digits above you have bar, that many zeros you need to multiply. First, you assume the given decimal as x, then that many zeros into 1, that many zeros you need to multiply for x. So, in the same manner, if you multiply this side also, what happens? The decimal point will be shifted here. Though it is a continuous repeating, right? One set you write here and remaining set again write and do repeating. So when you are subtracting this and this, these two will be cancelled, means it becomes 0. Now if you subtract these, you are going to get 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6. And this multiple, if it goes other side, divide. Now it is in the form of P by Q, where you can just say here that Q is a factor, the Q prime factor is other than 2 and 5. Where we have discussed if 2 and 5 there only, it is a terminating, it is a rational number. But in this case, it is different. Your denominator is other than 2 and 5. Right? Q is other than 2 and 5. With this, there is an end for your chapter 8 real numbers. In our next session, we are going to meet with another new chapter. Until that, keep watching. Thank you all.